Hey there, y'all. Today we're going to look at Unit 1 on exponential functions and Section 1.1 on simplifying radicals. As you look along the right side here, you'll see the unit outline as we go through. We're going to start with simplifying radicals in 1.1, and then in 1.2 we'll look at how to deal with that with variables. In 1.3 we'll talk about the law of exponents, and 1.4 rational exponents. In 1.5 we'll talk about graphing exponential growth and decay, and in 1.6 we'll talk about transformations of exponential functions, and finally in 1.7 we'll talk about writing exponential equations. So that's what we're looking at for this unit. But today we're going to look at 1.1 on simplifying radicals. And so the objectives for this lesson is two. Number one, we want to be able to rewrite exponent expressions or exponential expressions as radical expressions. And number two, we want to be able to simplify radical expressions. And that stems from these two standards from Foundations in Algebra, but we're going to continue this as we go through this unit and talk about how it relates into our standards for intermediate algebra. All right, so a couple of key terms we need to look at first. The radical symbol, this little symbol here, we're used to calling it the square root symbol, is used to indicate a square root, but it can also be used to indicate other roots. And so we see that the radical symbol can be paired with a number in the hook of the radical right here, and we call that the index. And so, for example, if we write this, we call it the cube root. Or if we put a 4 there, we would call it the fourth root. And so we can use any of those to be able to tell us what root we're taking. And so the first definition that we're going to look at is if we have a exponent where it's a fraction, 1 over n. And so the definition there is that a number raised to the power of 1 over n is equal to the nth root of that number. And so we would write it like this. b to the 1 over n is equal to the nth root of b. And again, I want you to pay attention to where that n is. It is not in front like a coefficient. It's up in the hook of the radical. Now, a couple of restrictions on b and n. b has to be greater than or equal to 0, and n has to be an integer greater than 1. And so let's look at a couple of examples on how we simplify these and convert them from exponential form into radical form. And so in example A, 1a here, the x to the 1/2 power. Well, this 2 becomes the root that I'm taking. And so I'd have the second root of x. But that's just a square root, so we could just write it as the square root of x like we're used to writing. But when we go to the next one and we look at x to the 1/3 power, now we have to have that 3 as the index, and we cannot lose it. It has to stay where it is. We have to write it as the cube root of x. Now, we could put in numbers for those, and we could look at like 25 to the 1/2 power. And so rewriting that, we get the square root of 25. And again, we don't have to write the 2, but we can. Just like putting a 1 in front of x when we write just x. And so the square root of 25, well, what times itself gives you 25? Well, that's 5. And then finally, example D, 125 to the 1/3 power. Well, again, we're going to write our radical. And so we have the cube root of 125. And so we have to ask ourselves, what times itself is going to give us 125. Again, what times itself gives us 125? Well, 5 times 5 is 25, and 25 times another 5 gives us 125. And so the cube root of 125 is also 5. Okay? And so as we simplify these radicals, that's what we're looking to do, is be able to simplify the powers that we see. Okay? And so in the next example, we're going to look at, well, what if the exponent's not 1? What if the exponent were 2 or 3 as the numerator there? So let's look at those. So now instead of having a 1 for the exponent, we have an m there. We're m over n. And so a number raised to the power of m over n is equal to the nth root, so you see that the root is still that denominator, of that number raised to the m power. And so we're going to write it like this. b to the m over n power is equal to the nth root of b, then raised to the m power. Now, can we put the power inside? Can we have the nth root of b to the m? Yes. That is also part of the property, but a lot of times it is simpler to take the root first and then take it to the power of m. And again, we have the same stipulations as before. b is greater than or equal to 0. M and n both have to be integers greater than 1 for this property. And so let's look at a couple of examples here simplifying these. Well, again, if I'm just dealing with a variable x to the 3/2 power, each piece is going to go its separate way. And so the 2 is the denominator, and so that's going to be our index. And so we're going to have the square root. X is what we're taking the root of. We call that the radicand. And then the 3, this power here, sorry it's jumping a little bit on me here, but we're going to take that whole radical now and raise it to the 3rd power. Now, with a variable, there's nothing else that we can do. But as we look at example C and D in a second, we're going to see that we're going to be able to do things in order. Example B, again, we want to take that denominator power. And so you might be working a little bit ahead of me here. The cube root of x, right? Because the denominator was 3, so the index is going to be 3. And then the numerator is 2, so we're going to take that to the 2nd power. And again, with variables here, there's nothing else we can do to simplify it. But let's look at C and D and see what happens. So in C, 25 to the 3/2 power. So again, the 2 is our root, so we're taking the square root of what? 25. And we're raising that to what power? The power of 3, because that was the numerator of the power. And so we can ask ourselves, what is the square root of 25? Well, what times itself gives us 25? That's 5. And that's still being raised to the 3rd power. And so what is 5 times 5 times 5? We actually did that a moment ago. 5 times 5 is 25, and 25 times another 5 is 125. Okay? So we see that we can simplify this in pieces. We can break up this originally fractional power and separate it into 2 pieces. So let's try it for 125 to the 4/3 power. What goes where? Well, the index is the denominator, so our index is 3. So we're going to be taking the cube root. What are we taking the cube root of? We're taking the cube root of 125. And we're raising that to the 4th power. And so we have to ask ourselves, what times itself is 125? And we've done this a couple times now. So what times itself is 125? Well, that's our 5 again that we just got a moment ago. And then 5 to the 4th power. Well, now we're going to take 5 times 5 times 5. Well, we just had that a moment ago. That was 125. But now I'm going to multiply by one more 5. So we get what? Well, 125 times 5 is 625. So again, we can see how we separate these powers out into their separate pieces. So we've seen how we can simplify radicals, but we also have some operations that we can do with radicals. And so we're going to look at the product rule and the quotient rule. And one warning I want to put out right now, you cannot add radicals together. So I can't take like the square root of 2 and add it to the square root of 3. And I can't subtract radicals together. You cannot do it without some other stuff. But you can't do it. Just don't do it. Don't take the square root of 2 plus the square root of 3 and try and get something else. It's not going to be pretty, I promise you. So, but let's look at the product rule and the quotient rule. So with the product rule, remember product is multiplication, the product of two radicals with the same index, and that's the key, is the index must be the same. So we have to both be square roots or cube roots or whatever the root might be, is equal to the nth root of the product. And so here it is in algebra. If I take the nth root of A and multiply it by the nth root of B, I get the nth root of A times B. And so we'll look at example A here. The square root of 8 times the square root of 2. Well, they're both square roots, so that's fine. And so I'm going to stay a square root. And then I'm just going to multiply these two numbers together. So I get 8 times 2. Well, that gives me the square root of 16. And so what is the square root of 16? Well, the square root of 16 is 4. Let's look at example B. We've got the cube root of 7 times the cube root of 49. Well, they're both cube roots, so I'm going to get the cube root of something, right? And product rule says just multiply those two numbers together. So I'm going to get 7 times 49. Well, what's 7 times 49? Well, go to your calculator if you need to. But 7 times 49 is 343. And if you need to use your calculator for this one as well, the cube root of 343 is 7. Because 7 times 7 is 49 times that third 7 gives us 343. And so the cube root of 7 times the cube root of 49 is just 7. Okay? So that's product rule, right? So again, we could take two radicals that are multiplied together and just put them in one radical and multiply the numbers inside. And that should help us simplify it. Let's look at the quotient rule. So the quotient rule says that the quotient of two radicals is the same with the same index is equal to the nth root of the quotient. And so we see where it's the nth root of A over the nth root of B is equal to the nth root of the fraction of it now. And so when we look at it like example A, we take the square root of 27 over the square root of 3. We can rewrite that as 1 square root of 27 over 3. Well, what's 27 divided by 3? Well, that gives us 9. And the square root of 9 is equal to 3. So we see that we can use these properties to simplify even further. In example B, we have the cube root of 32 over the cube root of 4. So we would have the cube root of 32 divided by 4 is equal to the cube root, well, what's 32 divided by 4? That's 8. And then what times itself is going to give us 8? Well, 2 times 2 is 4. And if we multiply that by another 2, we get 8. So the cube root of 8 is 2. So as we look at product and quotient rule, we're looking at how we can simplify these radicals through these properties. And again, I want to remind you here, you cannot add and you cannot subtract two radical expressions together. So again, we cannot do addition or subtraction. We can do multiplication, we can do division, we have properties for those, but we cannot add or subtract radicals. Okay? One last thing I want us to look at as we wrap up this section, we're going to look at simplifying non-perfect radicals. Everything we've looked at so far has been a perfect root. Like we take the square root of 25 and we get 5. Or we take the cube root of 125 and we get 5. But sometimes radicals don't come out nicely, and we need to know how to work with them and be able to simplify them into lowest terms, basically, kind of like a fraction. And so when we go to simplify non-perfect radicals, we're looking for perfect factors. And these would be factors where when we think about like 2 squared equaling 4 or 5 cubed equaling 125, we're looking for factors like those that we could divide out or factor out and be able to reduce the entire piece. Now, it's not going to change the value of it, if we were to plug in the calculator, it would give us the same answer. But it's going to put it in a simpler form, kind of like reducing a fraction. So let's look at the square root of 24. Well, we're looking for perfect square factors. And so when we look at square roots, we're looking for our perfect squares. And those perfect square factors are going to be like 1 squared equals to 1, 2 squared is equal to 4, 3 squared is equal to 9. It's all of these numbers down this list. 4 squared is equal to 16, and so on. And so, can 24 divide by any of those numbers? Well, yeah, 24 can divide by 4. And so we could rewrite this as the square root of 4 times 6. And we can actually use our product rule to separate this out. Before we were combined together, now we're going to separate it out. Well, we get the square root of 4 times the square root of 6. And the square root of 4 is equal to 2, so this is 2 times the square root of 6. This would be its simplest form. When we look at like example B in the cube root of 40, we could look at perfect cubes. And so with perfect cubes, we're looking for numbers that would be something to the third power. So like 1 cubed is 1, or 2 cubed is 8, 3 cubed is 27. 4 cubed is 64. And again, we can continue that list as far as we need. So can one of these numbers be a factor of 40? Well, we're going to take the cube root of, well, 8, right? Because 8 times 5 is 40. So 8 times 5. And so we're going to separate out those two radicals, cube root of 8 times the cube root of 5. The cube root of 8 gives us 2, because that comes back to this property here, that 2 cubes equal to 8. And the cube root of 5 doesn't simplify. And so we're left with 2 times the cube root of 5. Again, that would be the simplest form it could be in. And so in the end, as we look at simplifying these radicals, we're always looking for those perfect factors. And it could be a 4th power, it could be a 5th power. For most of what we're going to look at in these sections, we're going to look at perfect squares and perfect cubes. But don't be surprised when you see something to the 4th power, 5th power, and think about what factor might come out. Again, you might have to dig a little bit, but it'll be there. All right, so if you've got any questions, make sure you fill them into the video check form, and make sure also that you've completed your video check before class. If you've got any questions, let me know, and I'll catch you next time.